One, two, three. Hi, everyone. Thank you for coming on summer's Thursday evening. My name is Evgeny Potapov. I am one of the founders of this meetup group. We started on January with a couple of my friends. We wanted to give a talk on our experience of sharing AI coding practices among the development teams. And we wanted to find out some meetup group where we will be able to have a talk. But it appears that in Tel Aviv, in Israel, there was no AI first coding specific group, so we decided to start one. We got this place, and in January we had a first meetup. And then we decided that we'll be doing one meetup every 2 months. But then the war started, then we had some other problems, then months after months after months. So we decided that we can't wait longer. And we decided to, even though it's summer, it's not the best time for meetups at all. But we decided that we don't want to wait longer. But it's me again giving a talk. Last time, for those who were here, thank you for coming again. The last time, again, it was a talk about the best practices of sharing the knowledge about how to use, in what cases to use AI first coding tools. And now, at the time of that meetup, there were a lot of questions on how, what are best practices, how to use AI coding tools with large code bases, because there is a lot of specifics. The code bases are huge, many people work with them, and that's how we decided to make this talk. One thing before I start, we want to grow this community. We want to make a much bigger event in autumn. After the talk, I'll give a link to WhatsApp chat where we can get together. So if you want to participate in group, if you want to have a talk on meetups, if you want to help us to organize more meetups, to think how we can improve them, or just generally to have a chat where we can share the knowledge, please come. And if you have any ideas, or you have any questions, or if you have any suggestions on future meetups and the future of the group, please, after the talk, feel free to come to me and we'll discuss. I'll be happy to do it. So, a lot of people saying that in December 2025, a lot of things changed. In a single moment, there were Opus 4.5 and GPT 5.2 released, and it was a huge jump in the quality of the produced code. It was a huge jump of how many people who were skeptics before started to trust AI coding in terms of reliability, in terms of the quality of the code, in terms of performance. But and the reason for this are two things. One thing is the coding skills of LLM models per se. So basically, LLM model started to get more and more experience on how they do the code. And the second thing, which is more important for us here in this talk and generally, is the ability for models to do a computer use. So if we talk about how model code, it's API call, it's chat-alike. You ask to do something, you get the code base, you get the code file returned. But if you work with a large project, with large application, with large monorepo, we need to somehow discover all the code base, discover the architecture, discover how the different places of the code base relate to each other. And that's where the computer use comes to help. So a lot of people saying now that, and I'll explain about the computer use a bit, couple of slides after that. So a lot of people are saying that there is a magic, and even with large projects there is a magic, and LLM tools, Claude Code, Codex, whoever, can do a great coding even with large code bases. But a lot of people still don't understand what is the magic. How is it possible to, for the Codex, for Claude Code, for any other coding applications to work with those large code bases? And the thing is that there is a revolution in models. There is a new version of Opus coming every second month. There is a new version of GPT coming every second month. And it's a huge improvement. But what allows to do the coding is a thing called harness. Basically, it's Claude Code or Codex as an application working with the LLM models they use. The application itself, it's not simple like we use two IDEs, right? VS Code, JetBrains, whatever. And we think of it like it's a tool to edit files. What Claude Code or Codex really are is that it's a tool that mainly not a coding tool, not a chat tool, but it's a tool that provides the information to LLM model on the whole context of the project. If it's a small project, it's easy. But if it's a bigger, huge project, there is a lot of things happening in the background, and we'll see what it is. So basically, computer use. All large LLM providers are trying to do autonomous agents. Like they all dream of Claude Cowork, of any kind of like autonomous LLM that will use the computer and will be able to discover something that user will ask. And as the first step, they actually did the computer use case. The LLM now understands how to work with provided tools that will help to discover the things inside the code base. So LLM model decides on what tools to use, and we'll see it a bit later how it's working. So again, I think many of us saw that the models are doing good with large code bases. But I don't know, did anyone understand fully, do anyone understand fully on how specifically Claude Code or Codex discovers the code base, discovers the large code base? Because for all of us, it's like a magic. Even for me, it was a magic. So for this talk, I decided to discover the whole process of discovery of the code base, on how all the large code bases use it. Luckily, in April 2026, the Claude Code source base was legally discovered, published on the web. And we have, we can get session logs of the Claude Code interacting with the code base, and we have source code of Claude Code of version 2.1.88. And what we can do, we can get a GitLab source base, which is a huge 20 years old source base, and we can get Claude Code, we can get source code of Claude Code, and we can get source code session logs, and I took them together. And they decided to execute single prompt, like understand the whole project code base architecture in details. We'll be working with it. Once you understand, let me know, and I'll ask you to create docs on the architecture. And then Claude Code started to discover GitLab, huge GitLab code base. And because we have sources, because we have the session logs, we were able to discover the whole process behind the Claude Code discovery. And there is a lot of very important things that we can get out of it. Because if you want to work with large code base using Claude Code or Codex, if you want to prepare the code base or prepare agents.md, Claude.md to improve the quality of how Claude Code works with this project, we need to understand first, and that's the thing that not too many people understand, on how Claude Code works with such projects, what we need to prepare for Claude Code specifically, so it will be able to discover the information about the architecture better. So the first thing it does, basically the whole discovery process are 4 steps. The first thing it does, and it's very important, it's going to be happening more and more at every step, it uses a number of bash tools to discover the shape of the repository. It understands that the scale of the code base is massive, so it needs to do a quick orientation. But quick orientation, by quick orientation, you need to understand it's basically ls, it's grep, a couple of grep calls, and if it's a Git repo, it does some number of Git commands, and the goal is to understand the whole tree of file structure of the project and do something based on this. The second thing, so after this step, Claude Code understands the file structure. But there is an important trick I will tell a bit later. But the thing is that once the whole file structure is discovered, not yet a code, based on the file structure of the project, of large project, of middle project, Claude Code decides by file names, by folder names, and by the file structure that it needs to span sub-agents. And you see here that it understands that it needs to find out Rails request lifecycle files, API and GraphQL layer files, and so on and so forth. All of this was received basically only from the Bash tools discovery. So it's not kind of like something, it reads files, it sends the files to LLM. It's not the content. It's the file list of the whole project, but not the content of the files. Then every sub-agent runs on its own. So basically it spans 6 parallel sub-agents. Each sub-agent do pretty much the same as the first step, but now with file reading. But again, as you can see, you probably saw this in the your own sessions. But what's happening again? There are 2 kinds of tools. I'll tell about this a bit later. There are bash tools, regular bash tools, where it's find, it's ls, it's ls again, it's find again, and the read tool. Read tool is Claude Code specific. It reads the file. So for a specific need of Rails lifecycle investigation, it looks again over the files that there are in the code base, and then based on what it found on the file names on the tree structure, it decides to read files. Then the goal of the agent is to provide a summary. This is one super important thing I will tell later. Let's say you have a GitLab with hundreds of thousands of code lines, code base. It spans 6 sub-agents, and it has 10 kilobytes limit on what sub-agent provides as the result. So the main Claude Code, as a result of sub-agent executions, receives kind of like a file that is an index of the specific area of the code base. And we need to understand this is very important. Explore sub-agent, the goal of explore sub-agent is to provide to Claude, to main Claude, the index information of the whole file structure of specific area, so it will be able to investigate specific places of the code base later with a focus once it will decide to do something. So again, this is one important thing to look into. The explore code agent, the explore agent returns index of the code base. It doesn't return like a deep code analysis. It returns the base, the code index that Claude will be able to use later. And the limit is 10,000 chars. So if you do the code exploration, if the code base is big, and if you see that Claude spanned sub-agent, explore sub-agent to investigate the code, know that the limit is going to be 10 kilobytes only, and it's better to tell the Claude for exploration task that you don't use sub-agent in such and such case. But let's get back to the process. So basically, code uses only 3 tools. One tool is explore sub-agent that we saw before. Second tool, third tool actually, is a read tool which reads files. And the main tool it uses is a bash tool. Bash tool is basically a command line commands. That's why we're coming back to computer use of LLMs. Basically, what Claude Code and Codex, what OpenAI and Anthropic are doing now, is that they provide LLM with a Bash CLI agent. There are a number of things focused on development. Basically, LLM, like in Claude Cowork, LLM has access to CLI, to command line interface, that it understands how to use to explore the code base. And that's why we see all this ls, find, and other commands. LLM decides that it's kind of like a human who investigates the code base provided. And that's the limit. That's a very important limit that we can understand now. A single human trying to understand a large code base, even very smart human, might miss the things. And here is what we see, what's happening while this exploration using the bash, using the command line tools happening. Claude never reads full content of files, almost never. So what it does during the exploration is that it reads the first 50 line, first 30 line, first 80 line. It doesn't read more when it does the explore task. It lists the directory, but it gets only first 20 files. Again, first 40 files. It lists files in the database folder, but for some reason it does a tail for last 80 lines. Proc file, 50 lines, and so on and so forth. So it's like you ask the developer to overview a very, very large project. Of course, GitLab will be too much, will be overkill for a single developer, but we still have kind of like a developer who is trying to get overview of a project, and the developer understands that it's not possible to know everything. So it's basically like reading a book. So developer opens the book, reads a bit, one book, reads a bit, second chapter, third chapter, and so on and so forth. So what we understand here, it's just trying to get the overall overview about the project by reading either head of the files, either the tail of the files. If you'll see, so I did this whole investigation with GitLab, with Claude Code, and if we see that for 150 files, only n lines of the top of the file were read. For 143 cases of using find, again head. For 68 of 124 files read, only 70 lines of the files were read. Same for find, same for listings, and so on and so forth. So basically, when we ask what's the magic in understanding in how Claude Code understands the code base, there is no magic. As a first try, with a really big code base, it doesn't understand the code base. There might be several cases while Claude will explore more and more information, but we need to understand that the scope is very limited at first iterations. Again, so of multiple files read, 94% of files wasn't consumed, 95, 90, 79, and so, and it's going on, it's going on, it's going on. Overall, of 18 of 104 files opened by Claude Code, only half of those files was really read. And we need again to understand that it's kind of like a very high overview. But what we can do about this? How we can help Claude to understand the code base to do what it does really good? How Opus can develop the code? What we can provide to Claude during the exploration so the understanding will be better? Based on what we saw. First, there is a limit on what Claude reads. Okay, then let's do files within those limits. Usually it's up to 150 lines until the limit is reached. And usually it's first 50 to 150 lines as a first exploration. So what we need to do is we need to keep the very, very important part in this first 50 to 150 lines. If Claude receives this information, then it can explore more. It can understand that there is something important in this file and we need to read more. Second thing is that for documentation, we need to put the most important part about the what's in this file, in the specific file of the documentation, in first 60 lines of the documentation, in first 60 lines of the file. We can explain that this is a very important document that Claude needs to read to understand fully the scope of the whole architecture of what this document describes, for instance. First 60 lines are super important. As we saw in the, yes?
Sorry to interrupt, by the way. Agents.md, agents.md works in the same way. So Claude Codex read this file also on the partial fragmentary, or it reads till the end.
What I saw, what was funny is that at the beginning it reads the whole file. But we need to remember that after 1,500 lines, something will be missed, because 1,500 line is the limit where Claude starts to break reads from the file. So ideally, should be up to 1,500, but in the middle of the long context, when let's say it's 300 tokens, 300,000 tokens already used, Claude from time to time tries to remember what was in agents. And at that time, to remember what was in agents, it reads first 500 lines. So generally, the most important part of Claude MD or Agents MD should be first 500 lines. The overall size shouldn't be more than 1,500.
And how if crosslinks?
Crosslinks doing good. Crosslinks doing good.
So if, for example, I have more instructions, so I just can put there a crosslink and it will go there and won't tail it, won't cut it. Yeah?
Yes, in a couple of minutes I'll show how we do it. So yeah, but works, doing good. That's actually the thing. So because actually even not so for in the middle of the long context, it reads not 500 lines, but it reads 200 lines, first 200 lines. So the most important information first 200 lines, overall information up to 1,500. So we need to limit Claude and agents, but we can do the references there to other parts of documentation because it follows well. Again, the first step of the exploration is single directory search, traversing. Good file naming, good folder naming, matching the directories, the architecture of the project quickly gives Claude the understanding of what's the architecture of the project based on file names and folder names. That's crazy, but yes. An additional important thing is whenever you see sub-agent that was spent, you need to understand that it's not a magic, not a huge amount of brain dump will be passed to the main agent. Only 10 kilobytes summary. Big problem is that it's only bash tool usage. So instead of using bash tool, there are LSP plugins. LSP plugins is something that you can use in IDE when you click function and you jump to another file. There is a way to do this information, to provide this information about the connection between different files, where the function is located, where this variable was defined, using LSP server. But the problem with LSP server, which IDEs are using, is that it consumes a lot of time, and for large code base it consumes a lot of memory. For instance, for GitLab exploration, the first exploration task with LSP took 20 minutes and consumed 30 gigabytes of RAM. So it helps sometimes, but you need to try and test if it helps you. What it does, instead of doing the find, instead of doing the grep, once Claude understands that it needs to find some variable or function, it goes to LSP server, and the LSP server provides all the relations in the code base. But again, try. It's not a magic because it can consume a lot of memory. But
not tokens.
Huh?
But not tokens.
Not tokens, but huge amount of memory. Like I saw 64 one time, 64 gigabytes of consumed. My laptop basically stopped working. So, but overall advice. So all of what I was explaining right now was how we can survive, how we can live with the way how Claude Code explores large projects. But we can do something something instead. We can do the work of explore agent ourselves. We can create docs on project structure. We can create docs on design. We can explain data models that are in the code base. We can break down the project structure into domain scopes and create the whole scope that explore agent should be creating, but ourselves, and then point Claude to this created documentation. So basically, the idea of harness, the idea of Claude Code is that it limits what LLM can do. And what we should do while creating this documentation, exploring documentation, is we should limit what should Claude Code do, which is limiting what LLM should do. We shouldn't allow Claude to do find in the code base. We can explain where the files are located. We should not allow Claude to search in files. We can explain from the start where and what is located. We shouldn't allow Claude to read only first 100 lines. We might explain that such and such files are important. There are important source codes there, and it needs to read them in full. Now, the best way to explain how to organize such documentation is to show how we do it. So I'm a founder of observability company. We do ML observability for companies doing large ML trainings. And we have a pretty big monorepo, and we, for a couple of months already, work in this environment, and I'll try to show you by example of how we do it. But generally, to understand what I'll be saying about, to understand about the product. So the thing is that we collect data from the infrastructure, we put it to our data storages, we have a web front end, we have a web backend, and we have some kind of AI agent that does investigations for ML training incidents cases. And here is the prompt that we typically execute for a start. It's pretty big. But the whole idea again, and I will just jump to the prompt a bit later with details, but the whole idea is again to do a harness for the harness that we have in Claude. So for each prompt, we have a file defining the format of this prompt. Again, I will show you it in a minute. We have agents MD very well defined that will be read after the first prompt, and then agents plus prompt will proceed with the reading of the whole exploring documentation, so Claude will be able to read it from the start. Let me show you how it's happening. So first, to understand some context, here's the way how we organize the repo structure. It's a single monorepo with multiple services. We have a services folder where we store the services that are built with NX and related things that are closely coupled. One important thing for us is the apps. ApexData API and ApexData app services. ApexData app is a front end, ApexData API is a back end. Then we have submodules folder that is an independent repositories that we use along other projects together to work with. So here is the prompt to understand. Before that, I want to start some comment that I'll explain at the end. It's gonna take something like 20 minutes, I believe, so it's gonna end by the. So what we are able to do with all these structures that I will say is that Groh is an agent that sends the data. So I can say, understand how server agent sends the observability GPU data that it collects to client clusters. Understand our front-end application and understand our back-end applications. Those are web applications using this data. Use data access skill, and this is skill that provides information about the databases to Claude. To reach the data we collect and validate your understanding of how we are using this data, and use playwright skill to look at the web page of the web application. And then I ask to come up with some additional changes. So the prompt we typically use. First, it starts to defining what we are building and where is the full plan. It explains briefly the implementation part. Then what's really important is reference material. 1 second, sorry. One second. Oh, yes, it's here. Yes, so super important thing in the prompt that we provide is the orientation. We want Claude to not to use explore code itself. We provide the whole information about the organization of the whole application, whole monorepo. We say read the documentation in this order. Agents MD located there and there. Overall implementation specification of the project here. Specific scope of the project here. Specific problems that we have here. And then we provide the overall design of the applications that we are working on. And the additional previous cases that we were using, and more and more and more and more. So we try to provide the whole context in a prompt. It's a starting prompt. It's a prompt when there is no memory. What's in the yes?
Maybe I missed something. What is it? It's a prompt?
It's a prompt.
It's an initial prompt?
It's initial prompt for, so for...
You enter the repo first time, or what?
So that's the everyday process. So that's everyday process.
Right? Because it's more looks like I don't know, some kind of orientation skill or.
Let's say we have iteration number 22 for our specific project. What we do is that we need to define the overall context, because we are going to be, the scope is big. We are going to run out of context every couple of hours. So we need to build the foundation how Claude, every time the context is cleared, will get the complete understanding of what Claude is working on. Usually what people are doing, they say provide, store the memory, right? Store the information about what we are currently doing, create a handoff file. I do not trust this case, because as we saw, it's kind of non-deterministic. It might, one time it might store one information, second time it might store another information. So what we do is we have defined documentation on the whole architecture of the applications that we are doing, and we have a defined implementation plan of what we are working right now.
Okay. What about to split so big task for, I don't know, phases?
There are phases. There are phases. Phases are.
You Yes, but looks, no, maybe something written in the end, but it looks right now that it's all prompt you are sending to Claude Code. After that, who executing it, and after that, what Claude will give you after it. He will just say, okay, man, I'm ready. I know the context.
Yes, and then it knows the phase-by-phase plan, and it does, like, let's say, a phase 1 that was defined in the implementation plan.
It will go phase by phase without coordination, or what?
Until so
finish phase 1. That's what we are doing. Right?
Once let me show the overall process, and
it's a part of question. Actually, the main question is why you're not using why the approach with the let's say orientation skill plus small prompt for execute with plan MD of the execution feature and fragmented execution of this plan. Why this approach is why you're not using this approach, and why it's maybe worse?
You mean why we don't have implementation plan, or you mean why we don't have implementation plan, or some? Could you please?
As I see, as I understood you, maybe once again, maybe I'm wrong, but you're giving the Claude a huge prompt. This prompt is generating a huge amount of context for you, and you are working inside this context. Maybe I'm just using the Pro subscription, not the Pro Max, right? But it's I don't think it's usable, because for me, as I see right now, I'm just mentioning, okay? So I would write an orientation skill for Claude that will know that where I need to go, cross-linking, the design idea there, architecture there, blah, 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 all the stuff. And after that, I will provide him a plan, what scope of feature and phases of realization of this feature, and I will execute phases differently, so separated. I mean, so I will, every time I will leave the context, or it will compact the context, I will enter the, once again, I start from prompting, once again, orientation MD, orientation skill, phase 2, orientation skill, phase 3.
Why we don't do this is because basically this prompt is kind of like orientation skill, but we adapt each phase. It's not like a single orientation skill about the whole scope of the project. The project is too big. We can't do a generalization of the skill for all the project. For each iteration, we first do a large implementation plan, which we have, for instance.
So you mean each orientation?
The prompt itself is orientation.
It's part of planning?
Yes.
So you're preparing actually orientation map?
Yeah, so what we can see here, so prompt is basically the orientation. We say we're working on scope 22. The whole plan of the scope is here. What we are doing in this scope at a high level, we'll do item 2, item 3, item 4, item 5, and so on. Then we say what we had from the previous research and previous iterations of the implementation, because we need to have some background. At the previous end of scope results, we stored the results of what we did, what we found out, and how we can reuse this knowledge later. Then we say that here is the general information about the project at this moment that it could read. The alternative idea might be using the skill, but we need to adapt the skill each scope as well. What we are trying to do is we save these prompts for each scope of the we implement. So we'll have a history of how we changed this orientation and this. Yes?
Okay, so just for me to understand, like there is a problem, I understand, like of the context overflow. You have a huge codebase. If you do the orientation skill for everything, Claude will just give like, okay, I have a shallow orientation, and then I will go to every orientation, and then it will go to the deep level of each of the model, which we don't want. And then we use this approach, and then we allow, okay, Claude, you know how to shallow read these things, and this is going to be your map. But you say that there will be an important file still that will ask Claude to read fully. So how do we defend ourselves from the context overflow? Again, like it's the same problem.
Let me start from agents, by the way. So it's going to be easier than a huge prompt. And the other thing is that what I think is that we now came to the place, to the era, where we should have two kinds of documentation. One is the documentation for humans, other is documentation for agents. And the documentation for agents should be done in very strict ways. For instance, up to 1,500 lines per file. No need to provide any kind of opinion, future plans, and so on and so forth, because it can erode the context. And the whole idea is kind of like a context engineering of the documentation, is to make sure that it won't be too large. What we are doing ourselves is basically that once we go to the next scope, I look into the amount of context that was used during the load of the orientation. If it's up to 100K right now, then I'm good with it. If it's already like, if we read the docs and it's 200, 300, it's overkill, and we need to do something about this because it already overkill.
Maybe you will mention it in the future, but I can imagine like some rules like don't go into the depth of the module if you don't touch any file.
Yes. So let's look at this agent. So basically, I split the agent into agentsmd into four categories. First is global rule. Never read README for any information. We keep README for humans, and that means that Claude never needs to read, because it's a documentation, it's something useful, it's our opinions. We don't want to make the context dirty because of that. Never update README is obviously that it doesn't need to update docs on its own decision. When working with submodules, do not read their agents or Claude. We have multiple modules in Monorepo, and some modules are developed within this specific model. So developers might add their own agents. We don't want not to do this. Do not explore project folders unless specifically asked by user. Always read the documentation first. So the idea is that we have multiple projects, and we don't want Claude to go over all of them. And we don't want Claude to go to Codebase to do those finds, grabs, and so on and so forth. For each project, we have a documentation, agent-focused documentation that it can read. The big problem is to keep this documentation up to date constantly, because if it's outdated, it's a big problem. There are several folders that we use that are always git ignored, and the Claude shouldn't read them at all. Service isolation. When asked to work on a specific service, work only with that service folder and its documentation. Do not read, explore, reference code in other services or submodules. Only, for instance, if working with services up, never look into other services and vice versa. So the idea is that we have a scope of one service, and only the developer might ask to look onto other services as well. So what I usually do is when I work with frontend, I say, understand the frontend, but understand how backend works. So then it goes to two different services. But until that, only a single service. One of the tricks is that I say always to use context 7 MCP to avoid, context 7 MCP is a MCP that provides up-to-date documentation for everything. So if there are repeated bugs, it shouldn't think on its own. It shouldn't try to fix. It should go to this MCP. Claude tends to use internal memory to update internal memory docs. For a large repo, the problem is that we have a lot of developers, and they each work in their own project, in their own branch, and the memory file, we don't want to trust it. We say that Claude, whenever it updates memory, it should update docs as well. So this memory will be shared among the developers. Reminders is a not so critical thing. It's as I said, first 200, 500 of lines are important. So here are the things that Claude frequently forgets. For my case, it frequently forgets how to reach servers, dev servers that it will use for the development. So I remind them how to use it. Now, service reference. is basically the scope of services that we work with. The list of services in monorepo, how we reach them, and now we are interested in growth. Yes. So that's the example of where I will share more docs. These instructions apply only when working with submodules growth. So it won't read anything if working with other submodular. Do not explore this folder unless explicitly asked by the user. Growth is explanation of what it is. Then we have design documentation. Design documentation is where we explain how the code is organized. We have implementation notes. Implementation notes is kind of an index file that we provide to Claude. It's a really big file, so we say there we have TOC. TOC is super important because again it's first number of lines that Claude will read and understand how to work with them later. So we explain how this overall project is organized, what we do inside. For the documentation, our developers, we don't do simple like superpowers brainstorming anymore. What we do is we, for any new service, we basically for a couple of days we talk on the architecture of how the service will be implemented. The idea is that we need to frame Claude in its own implementation of the service that we'll be working on. So we need to explain what are design decisions and how to follow them. Interesting part is that having mermaid charts in docs help a lot. You can define charts. It will be understood by the human, but it will be very well followed by Claude as well. The overall initial doc, overall design doc, contains links to all of the specific design files. So we provide design docs, implementation docs, specific implementation plans, example of the following prompts that will pass the context, and several related documentation and source code as well. So the idea, Claude gets the prompt. Claude goes to agent.md and understands the scope of the prompt. Then Claude understands we're working on this such and such service. It goes to this section of agents.md and it understands that it needs to understand the design first. It understands the design based on the overview docs. It understands the implementation notes and it's focused on implementation notes. Then it reads implementation plan and then it starts implementing once I'll ask Claude to implement. So the multiple idea is that the prompt, it all loads the context about the service. We have zero context, we need to load it. Prompt loads the context from the, Claude loads the context from the prompt. It then reads agents. It understands the documentation about the specific project, specific application. Then it jumps into it and then it reads the documentation inside. Only after that it comes to the implementation plan for a specific scope. We don't push the whole scope in a single iteration, but we say that you have multiple items on what to implement, and then we go phase by phase according to this implementation plan. So the way how it's going. Prompt, then agents, then nodes documentation about the design docs relevant to the implementation, and then the implementation plan. What we have in the prompt itself, the overall goal of the scope, the critical context that is needed for this specific scope of the specific application, the orientation of how this application is developed, reference materials, if for instance we have rare frameworks, rare data, and additional instructions that Claude frequently forgets. Structure of agents.md, global rules, reminders for things that Claude frequently forgets, services reference service by service with the limitations that Claude only needs to read this one, and reference documentation about additional things. So for reference documentation, they usually provide the database structure of the specific services. So Claude will understand how to reach the data and understand it. I use two specific skills created for our needs. One skill is how we frame the Claude when it works with the data. For each local development environment, we have a skill that Claude can use to access ClickHouse, to access Victoria metrics that we use, and use Postgres. So when we ask the backend to go to the database, we ask Claude to first, once it invents the query in the code, to use this query to access the database itself, to see if data will be received and to see if the data will be correct. Another skill that we have is the playwright skill. So whenever we work with the front end, we always say Claude to use playwright, to use the browser, to see how the front end was implemented. And I hope by that time yeah, so we can see how it worked here. Okay, it's not what we expected. So,
I have a question.
yep.
If I'm writing an application or a project using Claude Code from scratch, then Claude Code manages its work like that, creating a context file, README files, or I need to instruct him to do
It will do it. There are some commands to do memorization of what's happening, but the way it does is only working for a small project. Ideal case is that you need first to talk with Claude to define the design of the applications that you're doing. You can say, I'm going to do such and such application. Suggest me how you would implement this application and explain the reasons of why you did this, why you decided in such a way. Then you can discuss the application architecture, and you can say, okay, let's store this architecture in files. And then you can say in AgentsMD that once you work with this application, first read the design files of what we designed. And then you use, with this case, you know specifically what was stored. Because LLMs still hallucinate, because there are some information that might be not important for future cases, and there might be missed some information that is important.
So you have to supervise what is.
Ideally, yes. Ideally, you need to supervise because you will first understand what's going there. And second, for any future cases, you will limit of what Claude will be doing after that. Because the main problem is that the history is limited. It will need, every time it will need to understand the context that was before.
So I can instruct him, create a context file for the next page, right?
Yes, but you need to read. Every time it will be a bit different. As we saw, it reads only a part of the project, and it tried to do some decision based on the short information it knows. So basically, you need to double check every time. Yep.
What do you do in order to maintain all these complex files that you store? Like you have like you presented like 50 markdown files that are all like really huge. So how do you keep them updated with the codebase that keeps?
Once they're done, it's much easier because what Claude does good is it already follows the defined structure of the content.
So like you would trust like whoever, like obviously it's Claude Code delivering the feature, but you would trust the developer to update the files like with the feature that it implements and update the documentation.
We read docs. We read docs. where is the documentation? The things that currently, the way we do, so let developer gets the task.
Yes.
The goal of the developer who working on the task is to provide all this bunch of the documentation that will be provided for Claude for the review of the manager.
Yeah.
So once it's done, again, the PR obviously is a huge one.
Yes.
But along with PR, we do update the documentation of what was done.
So it's along with that, with the implementing of the code changes, you implement the documentation, and you don't have like any scheduled task that reads all the code and tries to.
Once implemented, we say update the documents.
Okay.
And then with PR, the goal of PR reviewer after that is to review document changes.
So you switch from reading code to reading if the documentation fits the.
Well, PR might be 10,000 lines of code, but the documentation is 1,000 lines. Yes?
It's
So, did you measure output from all this configuration?
What do you mean?
Like, what's the biggest benefit you got?
The biggest?
Benefit.
We were able to, so generally, for our case, it wasn't like the improvement of the process. In many cases, Claude started to do a poor job while we knew that it can do a good job by constantly losing a context. So we needed to figure out how, first, why it's happening. That's why we found out this whole process of exploration. Then we found out how we can prevent this. So generally, it's not like a measured in terms of numbers, the experience, but basically we started to be able to work again. The goal is not to improve, but we got improved, especially with Fable. But to get a baseline of where we can continue the work to work on the large code base and with large scopes of changes.
So you mentioned this thing interesting that in the pull request, the reviewer reviews the documentation and then so the code review is the bottleneck now, in fact. And so, like in theory, we don't need to read code anymore. And we can just review these changes of the documentation if we can trust that code consistent in producing this documentation and updating it. So, but from your experience, did it work? Like you say, like reviewing the documentation, like how did it work? Do you need still to read all that?
We have strict rules on TDD first approach, on basically testing approach. So it's always should be covered with TDD first. And ideally, let's say we say about the agent that we install on the server that collects the data from the server and sends them to the database. With every scope, along with the whole implementation, code implementation plan, with this handoff prompt, we say, before the implementation, go to the test infrastructure, do a script that itself will collect the data from servers, process it and store in the database where we store it finally. Then, once you develop the new version of our agent, deploy this to test infrastructure, let it write to the database, and Claude then checks if the database data coming from agent matches the data that was like a ground truth.
Okay, but all this mock data and unit isn't tests or unit computer level, like it's no code. You need to read it. And at the end of the day, this is my problem. Like if I can read only the documentation change, it would solve like everything for me. So from your experience, like do you still read every single line of the
Some PRs are 10,000 of lines. Even we try to do PRs of smaller size, but some PRs are now 10,000 of code lines, and it's. But yes, there were a couple of PRs that were like a lot of code was there. But we tried to cover with tests. Every developer should write tests. Hundreds is now normal. Hundreds per scope. Hundreds of new tests is normal. And ideally we have integration tests as well. So it should be all covered.
How does it helpful, like, with so much of tests, like, they are supposed to be a specification for, like, some functionality, but then if there's so many, like, how do you read it? Like, you read documentation at the end of the day, right?
Claude does good, Claude does...
So it's for Claude.
Yeah.
Yeah, all this.
Yes. Not for human to run them. So basically it's a framing. It's a framing, what LLMs still hallucinate. Basically they still hallucinate. What Claude Code comparing with Cursor was doing good is that it was like if you have tests, it sees them fails, and it's just do another loop, do another loop, do another loop until the hallucination is resolved or bug is resolved. So test is a way to cover them with the framing that will help to reduce amount of bugs. 100 tests, bigger de-risking of the whole process. What I believe right now is that with TDD first approach, we are now close to the amount of bugs that will be introduced by human. So basically, when we say there is a question of trust of how Claude Code does bugs, there is also a question of trust on how human do bugs in the code. And right now I think it's the same problem. Of course it's easier to find bugs with a humanly developed code where it's just like 100 of lines of code. But it's the life we live now with
let's go back to our context. Okay, maybe I need to apologize for this question. I'm trying to figure out what issue you are solving by this approach. It's economy of computing, it's economy of tokens, it's providing clear and increasing quality of context. What are you achieving in the end? What will happen if nothing of this will not exist except, I don't know, simple agent instructions like go there, look there, don't touch this, don't touch that. So what will principally change?
The code base is huge.
What is huge? Let's terminalize the term.
Yeah.
What is huge? It's
1 second.
Right?
Right now it's 400 keys, 400,000 lines of code.
Like relatively to context window, how much is it? So context window is
Indefinite.
yeah, like it's not comparable.
yes. So what you're solving?
We need somehow to load the context, the relevant context in the cloud.
Okay, that's what I'm asking. If you won't provide this context, what will happen?
It will go with.
It will be overloaded. So it's literally it's what you're trying to say.
If you won't provide the content.
It's impossible to provide whole context of huge code base to go code. This is the issue you're trying to solve.
If you want direct on where to go, it will try to find itself. And it does this very poorly. It tries to read 50 lines of such file.
After that, I think you skip that, but after that, if he will go there, a little bit deeper inside your feature, what you actually need to implement, he will go inside some specific, I don't know, controller services, I don't know, slices, or what kind of architecture you have. So it will go inside a little bit, will go a little bit deeper after first shallow.
We need this faster. We need this much faster. And there is still a question of good luck. It provides the speed, and it provides us the reliable knowledge that the whole relevant context is loaded. And it also frames Claude very much on how Claude will implement the feature.
Okay, and how it affects on cost, on money, on usage of tokens, how much do you pay?
It's subscription.
Subscription? What do you mean subscriptions?
I mean, it's a $200 per month subscription. We don't pay for token.
Also, they have limits there.
It's insane amount of size.
So you are under these limits?
For our typical developer in token price, I think we consume, we don't pay. I mean, if we will be paying for token price, we will be paying something like $5 to $7K, but you pay $200 per month.
Okay, so this was my question. You're under this limit.
We under
Inside the limit that provides $200 per subscription.
yes. It's very hard to reach the limit of 200.
It's possible.
It's possible?
Yes, it's possible, and a lot of people in my former manager is facing it right now. They are developing some kind of AI stuff, I don't know what, and every week they're hitting the limits. So.
Okay. Yep.
What do we try to give another aspect of your question? It's not only the size or the cost of the tokens. If you ask a question which is not focused, and Claude is going there, grabbing the entire codebase, running many tools, and then comes back, and first he has a lot of context that he doesn't need, because he used many tools that he didn't need if he were focused at the first place. Secondly, you will see it every day. Once you get above, I don't know, 200K, 300K, and you go on, Claude is getting more and more stupid. Why? Because he has a lot of context, he has a lot of noise. So if you would like to go to a single file, to go to a single module and do something punctual, so if you use this system or other systems, when you talk about other systems, it's not punctual, you'll get a focused task that will end in X tokens. In your system, it could go around. Maybe it will save you only 3 minutes, okay, to go with this context focus.
Yes.
But you'll get a task which uses a lot of tokens for no reason, and besides using more tokens, which might or might not you care about, you might don't care, it will be less efficient and less correct, because it will use much more tokens to get to the bottom of the thing. You don't want. I will give another example, and if it's long, stop me, please.
No, it's fine.
I had in my company, I had the Claude Code presentation that I did, and I wanted to see what happens when I use skill versus non-skill. I took a very composed problem. It's called the DSL. Maybe some of us know it, the domain-specific language. And then I have some kind of DSL and a parser. And I ran Claude in 3 modes. First time, I gave it the spec of the DSL. It used that skill, and immediately it found me a fix for a problem in the language. With the skill, it was like that, 2 seconds, it used very little context. Then I gave it the parser. What he did reverse engineering to the parser to understand the language. He was out of it, but he used 10 times the number of tokens, and it is a very small language. So if I had a parser of, I don't know, 25,000 rows, it would take hours, and it would spend 100 times the tokens. And if I didn't give it neither this and this, and just need to go through the details, he came up with something totally bogus and fixed something that he could never know how to do. So it's this length, since good focus stuff, to do it reverse engineering for God knows how many times, to go into a totally bogus state in which he invents his own context because he couldn't find it. So you have all this range, and I could show it. I could show you this in a small, very concrete demo. So maybe Claude could go away and get away with the answer, but he might even stop when he thinks he did enough and just invent.
I will just respond. Before I came here, my solution was, no, I thought about it, but I thought it's too complicated. Maybe I don't know, or maybe I'm sure I don't have such huge data codebase, but everybody here is a developers. I think we use some kind of skills, tools, Python, blah, blah, blah. We are not using Claude like native. But my solution was, before I came here, is small fragmented tasks via plan. So if I have some kind of huge execution, detailed plan, and each my prompt is very small, very concentrated, and
I've got the difference. So in our case, one of our like a product level goals, product/tech product level goals, was that we wanted to get to the level where we can one shot a whole big iteration of the scope. Not a small prompt, focused prompt, but we need to do a whole iteration of the scope being done within one specific prompt, without going to different wrong branches, without going vogue. It need to be super focused. It need to understand what to implement.
So
it need to validate.
You received 10,000 lines
Working.
So,
Yeah.
okay.
I kind of,
That's enough. Thank you.
yeah, I kind of wanted to add actually to both of these use cases. It doesn't matter code sometimes, just, I don't know, think something, I need to investigate it to fully and like burst like everything. So as far as I know, your approach, why it's great, because when we get to the moment when the context needs to be shrink, we don't control it anyhow.
Yes.
So it's not determined, we don't know what it loses. And then when it loses something important, he can say, okay, I lost it, so I can go here and quickly refresh my memory. This, I think,
Yes.
for me.
Basically, you're right, because I kind of like reflecting, and we got this idea from the developing of our own AI agent, where we do context engineering, so every time agent starts, it will have enough context. So basically, we do context engineering. We strictly defining the context that the Claude will have for the implementation.
Yeah, and now if you run a team, for example, each agent needs to know the context and how it gathers it, right? Like it's another
Yeah.
approach.
Yes.
With this approach, do you ever reach the point when you need to compact the context? Like you have a lot of iterations.
Now the thing is different. So we try to we do not compact. We clear.
Makes sense, because like we should always avoid compacting the context.
Yes. So basically, it's 400K. We can just clear and continue.
In my humble opinion, if you're touching the context limit, you are doing something wrong.
Yeah. Yeah, but you know, like here, the context could be large, but you just make sure that it contains only the important stuff.
And about the idea of iteration development. So we had the critical projects that we needed to deliver fast. Thanks for Anthropic to opening Fable for 3 days, because it did a lot of great job. But basically, we were able to do 44 pretty large scope iterations within 2 weeks, with little amount of bugs introduced because of this framing. So the idea was, again, so one shot is working good right now with Claude. There are a lot of stories how someone rewrote the ban from Zig to Rust in a single day. So what we wanted to do, we wanted to achieve reliable one-shotting, where we can define the scope, we can put Claude to do this iteration, and we can work on something else while it's happening.
I saw like what you demonstrated before, like phase
Yes.
22 or scope
Yeah.
22. It was the spec for the feature, right?
Yes. So basically, we store the whole information about each iteration. We store the implementation plan for specific cases. We store also the snapshot of the data that was provided. We store the prompt in several specific cases, and that's how it was done one by one. So, for instance, if the new iterations comes bad, with the same context engineering, we can say revert the code to previous iteration, and it will load all the context that it had after the successful iteration.
I wonder, how do you organize the work? Like one developer gets one iteration, and then they work on this huge PR. What if somebody works on another iteration in parallel, and they might have...
Ideally, we try to avoid two developers working on closed scopes, because closed scopes can edit similar files, and with how Claude edits the files, it's going to be a lot of conflicts after that.
So you just try to avoid...
We try to do different scopes.
One more question is, like when you write the scope, okay, do you use some skills or maybe best practices, maybe, because like if you open any of these documents, like you, as you mentioned, you have some conventions for writing. And I believe you don't write it manually. So.
Well, honestly, how it happened? It's a wait. Honestly, how it's happened? We had design docs. Then we started implementing the core. So design were used for the implementation docs. Then once we did the core, we said, okay, now we need the implementation plan for the first iteration of further development. And how Claude did it was pretty good. So basically the whole structure was invented by Claude here. For the whole structure of this implementation plan, Claude does very good at writing implementation plan. What I'm trying to, right now, the only thing that I'm trying to avoid is that I say to Claude to reduce the amount of specific code line examples, code examples in the implementation plan. Because during the large scope implementation, if there are specific lines that are buggy in the implementation plan, Claude tries to use these specific lines. So we try to avoid code samples in the implementation plan. We try to do it high level, so it will be able to adapt. But we found the first version of iteration plan pretty good, and then we just were saying that based on the structure you had in previous implementation plan, create a new implementation plan.
So this is a technical implementation plan. This is not the product spec, right?
It's a product spec as well. Well,
like does it actually like say, I don't know, add a field on the form, etc.
yes. Let's see.
Question.
Mm-hmm. Yes.
So I guess there are many developers in your team, and the question is how many reviewers are reviewing the pull requests? It's the first question. Another question, you mentioned pull requests with 10,000 line of codes. Do you chunk them to merge?
Ideally, we try to chunk. 10K is an exception. We are not super big team. There are 5 developers, 3 tech leads. So tech leads do pull requests. Our head of engineering is still pretty control freak, so she checks the code lines. CTO and me, I try to, so if I know the tests were done, if I know that the implementation went good, that integration tests were done, and then we focus very much on having the ground truth data. It's not something simple mocks of client-alike data. We try to do the data as real as possible. So once the implementation is done, apart from doing the pull request, we do the integration testing. We check the functionality like a real user. And we have a lot of cases. We also send Claude with Playwright to do tests as well.
By the way, about Playwright, did you measure how many dollars it can consume? Because for us it was far behind the limit. And we just decided to stop using it at all for Playwright implementation.
You are using Playwright CLI or Playwright MCP? No, don't use it. There is a Playwright CLI and Playwright skill by Microsoft. So CLI is like 10 times slower than MCP. 10 to 50 times slower than MCP in token usage. So the thing is that MCP loads a lot of tools. Playwright have 50 tools. Playwright MCP have 50 tools. Those 50 tools is a text description of what's inside. Playwright CLI is a command line with ---- help.
It's also because of the images. Like you screenshot the actual images and the Playwright CLI gives you a YAML.
Yeah.
It's a lot smaller than full image for every tool you
Playwright CLI, I think it's something like 50K of tokens for pretty sophisticated execution. Yeah.
So I have several questions. You told us many interesting things. So about the data. So what about shared types? So let's have one package will have shared types, like TypeScript files for all the other packages. Do you use this approach? Why do you need think so much of the data in mocks if you have types?
Can you provide example of what you mean?
Like server-client communication, API server sends like some list of items to the front end, and then you have TypeScript there and there, okay? So you can have one package like common types and describe the contract, request and response between them, and reuse here and there in what. So it will describe the data basically, like that is used for the communication. The same we can say. We have models describing the database, so that doesn't solve it.
Why we do this is because why we do separate documentation for data. I mean, it's because we want the skill to be able to look to the database itself. So in the data model docs, we have examples of how the data is described. We have examples of the queries to databases, and.
Can you ask Claude, like, does he aware about the algorithms under the hood? Like, can I ask him, so you ask him, create these files, how do you trust it? Like, okay, by your experience, you can say it works. But if I'm just doing it from zero, how do I trust it? Like, or should I, like, you explain now this kind, because you analyze what he did and all this stuff. But can't we just ask it?
What do you mean? Sorry.
Revise my documentation files that they optimized for your scanning, like whatever.
I believe I'm a fan of outsourcing everything to Claude, but I don't want to outsource everything completely. So what I try to keep doing is I try to read docs, because I will ask to revalidate, of course. I will ask something like, double check it yourself and see if there is nothing vogue. But after that, I would love to review the documentation myself, because otherwise, look, we have this 44 iterations. If in the middle something will went off from the plan, the next time it will be used and will go off further, then further, then further, and the problem 10 iterations later we will find out that it happened.
Okay, and the last and not the least question, maybe the most important out of this all. There is a small toggle in the corner, you know, like the smartness of the Claude. Do you use it? Like, do you use, you know, like ultracode?
I don't like sub-agents. I tried to use ultracode, but it was buggy so many times that I stopped using it. I use X-High because max, right? The top plan is max. So I usually sit on X-High. I don't experiment with lower plans because I just don't know how to compare. I wouldn't, so I use X-High.
In the middle, like lower than max, not lower than max.
Yes. Yes.
When the code works, does it read the previous scope sometimes, but doesn't access the documentation of the previous scopes? To understand
we use the scope docs for the history just to see what we developed, and we use scope docs to revert to the previous stage. If the new scope is super buggy and we need to stop it, we understood that we did something wrong from the start. We revert the whole code base of the scope that we are working right now, and then we load the same prompt that we were using with the previous scope, and we have this like PR merged, scope PR merged, so we revert the merge. We go to previous scope and we load the whole context prompt, and we say that it was done. Then we can jump further. So it's kind of like a version history for prompt for context engineering.
And if you find a little mistake in the scope that was introduced, let's say half a year ago, and you want to maybe fix that.
If it's a small, we'll try to find out how to do this in this iteration.
So you will
Ideally, yes, but I think we'll do this in this scope, in the scope where we found the problem, within the same product scope.
So those files, they're not like readable. You sometimes can modify them and like reiterate on the previous scope.
I mean, let's say we're working on scope 20 and we found out that there was a problem on scope 15. So we kind of put, let's call this not scope sprint 20, right? So we put a task of fixing this problem in this same scope, scope 20.
Okay. But the scope 15 remains untouched.
Yes, like a history, just.
Because you know, like if in one of the sessions, Claude needs to read something in that scope, it will-
That's an interesting question.
It doesn't know that you fixed it in the next.
But we limit. Claude never reads scopes.
Okay.
Again, so
Unless it's focused on the specific task.
You interested say that it looks like revisioning, like for scopes or something that I got corrected. Let's use Git for that. Let's say the current scope explaining the current state of the code. Next time it will be updated and the Claude can go in the history.
yeah, but as a human, I want to look over the scopes to understand what was done and when. Guys, it's half an hour past when we wanted to finish. So if you want to go, feel free. It's like too much. I will stay here for next 30 minutes. So if you want to ask questions or talk, I'm here. Thank you.